So in this video, we're going to be looking at another type of proof called flowchart thinking. As opposed to writing a paragraph proof, this is another way that you could organize your thoughts for a proof. You start off the same exact way. You're going to take your givens and you're going to mark up the figure with what you know. So we know that EC is congruent to AC, so we're going to mark EC with a congruence mark there and AC. And then we know ER, so 2 marks there, is congruent to AR. And then we can see in the triangles that CR is going to be congruent to itself. So I'm already having an idea about how I can write this proof. With a flowchart proof, it really is sort of a graphic organizer with all of this information. You stack things that would lead to something else. So we might start off with like 3 boxes like this. And we might put our 2 givens would go in here. So the statements from your statement reason proof go inside the boxes, and then the reasons go at the bottom. So we would say this is given. Then our next thing that we knew was ER was congruent to AR, and again the reason is it's given. And then the third thing we knew was that CR is congruent to CR, and we know that because it's a shared side. Those 3 things together tell us something about the triangle. So I'm going to use arrows to say, okay, this right here points to this, along with this, and along with this. So these 3 things tell us that triangle ECR is congruent to triangle ACR. And then underneath, again, I'm going to put the reason, and the reason is side, side, side congruence. And then knowing that those 2 triangles are congruent, I can show that angle A is congruent to angle E by corresponding parts of congruent triangles. And there you go, that's it. There's your whole proof. So again, as you can see, this is more just like a graphic organizer sort of way, kind of an outline method for writing proof as opposed to writing those paragraphs. So you would do either one. You would either write the paragraph proof or you would do a flowchart proof. You would not do both for a proof. Let's take a look at this one. So again, we're going to start by marking what we know. We have SE congruent to SU, and we have angle E congruent to angle U. And we want to show that MS is congruent to OS. Sometimes it's really helpful when you have a picture like this. I mean, there's lots of triangles in here. I have this small one and this small one. I have maybe the big ones that I might show are congruent. I might want to talk about this triangle in here. I don't know. So sometimes it's helpful to separate the 2 triangles and redraw what we're trying to show. So I might over here say, okay, well, I think I want these 2 small triangles. And I'm going to rewrite them. I'm going to draw them separated just so I can get a clearer picture of what's going on. So this is E. This would be S. This would be M. And I know this is congruent to this. Again, this would be S, U, and O. I know angle E is congruent to angle U. And I have a 1 in here and a 2 in here. And I know that angle 1 is congruent to angle 2 because they're vertical angles. So already right there, I've got an angle side angle proof going on. So I'm going to start with my flowchart and I'm going to create a box for this first given. Each box gets its own statement. SU and the reason is given. And then next I would say angle E is congruent to angle U, again given. And then my third here would be angle 1 is congruent to angle 2. And we had a conjecture for that. It was vertical. We'll say vertical angles. Conjecture. Remember, the definition of vertical angles would be what those angles are, and then the fact that they're congruent is the conjecture. So those three things would tell us, those three things combined would tell us that triangle MES is congruent to triangle OUS, and that would be, again, by angle, side, angle congruence. And by that, we can show that MS is congruent to OS by corresponding parts of congruent triangles. So there's your proof. So that's all you have to do with flowchart thinking, is to draw that outline, and then you're done.